So we had talked about amplitude. We had talked about how that changes the height of the graph. Now what we're going to talk about, and this is, again, continuing on section 9.5. This is now talking about horizontal stretching and horizontal shrinking. Now we're going to deal with this one. It doesn't matter if you do with sine or cosine, but we're going to deal with something that looks like this. If we have y equals sine of b times x. Now that being said, this number right here is either the horizontal stretch or the horizontal stretch or shrink. Did I spell it right? Stretch or shrink. So this is either the horizontal stretch or the horizontal shrink. Now, one thing I want you to kind of remember about this is if I have a sine curve, the sine curve is going to go, it's going to look like this, where it goes up, then it comes back down and goes back up, and it just keeps repeating over and over, right? And we all know or should know that it goes to a height of 1, it goes down to a height of -1. The height that it reaches 1 is pi over 2. The height that it reaches 0 is pi, or the distance, I should say. This is 3 pi over 2, and then this is 2 pi. Now, we had mentioned that a period is just one full cycle of what happens before something gets repeated. So in this case, it is just this. So now we're talking about something being one cycle is 2 pi. Now, something I need you to think about with that is saying that the graph of sine, one cycle of sine, is 2 pi long. So think of 2 pi not as an angle, think about it as a length, like the circumference of the circle. Because if you think about it as a length, that's saying that that length is 2 pi. Now, if I do a horizontal shrink or horizontal stretch, the only thing that's going to happen is I'm going to take that 2 pi and I'm going to shorten it or I'm going to lengthen it. The horizontal shrink would shorten that 2 pi length, and the horizontal stretch would lengthen that 2 pi length. So what you're going to do to figure out exactly how much to shrink, to shorten, or to lengthen your period is you're just going to take your 2 pi and you're going to divide it by whatever b is. That'll tell you exactly how long your new function is going to be. So if I put a 2 here, if I said y equals sine of 2x, this is either going to be a horizontal stretch or it's going to be a horizontal shrink, but it's telling me that my new period is going to be 2 pi over b. Right? So it's going to be 2 pi over 2, which is pi. So this thing has now said, this one, the parent function had a 2 pi length. My y equals sine of 2x is going to have a length of pi, which means that it is going to be shortened by half. So this means that this thing has shrunk by a factor of 2. So if you remember back to what we talked about last year and what we talked about this year, that number in the front here is opposite of what the number in the front would do. If a 2 is in the front, it would stretch it by a factor of 2. If this number in here is bigger than 1, it's going to shrink it by a factor of that. So this will shrink this by a factor of 2. So now if I want to graph y equals sine of 2x, if I want to graph this thing, then what you really have to do is you have to think about what the parent function looks like. So let me start out just by graphing the parent function. And the parent function is what I had just drawn a second ago. But the parent function is going to just go up and then down and then back up. And I'm only going to draw one period right now so that we can see what it looks like. But here's our 0, here's our 1, here's our -1, here is our pi. This is, and then this would be 2 pi, which would mean that each of these, this one up here would be 3 pi over 2. I'm sorry, it would just be pi over 2. And then this one would be 3 pi over 2. So if you use common sense and you say, okay, well, I now know that my new graph, y equals sine of 2x, is going to have a period length of just pi, that means that my graph is going to start here and it's going to stop here. There are really 4 spots where something happens on a graph, right? Something happens at the end, something happens in the middle, and something happens at each quarter. So if I want to do this, I can say that I have a starting point and an ending point. I'm going to have something happen in the middle, and then I'm going to have something happen in between each middle point, and that's going to be the same exact thing, it's just going to be shrunk down. So a quarter of the way through the graph, my sine value goes up to 1. Oops, hang on. So a quarter of the way through my graph, this is a quarter, my sine value is going to go up to 1. A quarter or 3/4 of the way through my graph, my sine value is going to go to -1. And in the middle, it's going to cross at 0. So this is just me taking the big picture and scaling it down based on the ending point. So right now, I've essentially just taken all of these in half. So I'm going to take half of pi over 2. Half of pi over 2 is pi over 4. I'm going to take half of 3 pi over 2, which is 3 pi over 4. And then I'm going to take half of 2 pi, which is just pi over, or half of pi, which is pi over 2. So I've just rescaled this entire thing. So now I can make it go up to here, down through this point, pick up that point down there, and then I can connect that point right there. And I have now scaled this down by a factor of 2. So all I did was divided every single one of these by 2. And I just like to think about this in terms of like four spots. Pi has 4 important spots: pi over 2, pi, 3 pi over 2, and 2 pi. So all I did is I realized, okay, well, if I know my ending point is going to be pi over 4, if I have 4 important spots, make my 4 important spots. 1, 2, 3, 4. So I have my 4 important spots. And then I just know that I have to break that down as I work through. So let's try another one. Let's try one more. Let's try like sine of half of x. So y equals sine of half x. So if I take y equals sine of half x, I'm still going to do my parent function so I can compare my parent function to what's going on. So I still have my important points. This would be pi over 2. This would be pi. This would be pi over 3 pi over 2. And this would be 2 pi. And then now what I'm going to do is I still have my 1 and I still have my -1. Remember, I'm not changing anything with the height difference of my graph. I'm changing things with the length difference of my graph. So now if I want to find the new period of this thing, I'm just going to take 2 pi and I'm going to divide it by whatever b is. So 2 pi divided by 1/2. So we know that that's the same thing as saying 2 pi divided by 1/2, which is the same thing as saying 2 pi times 2. So my new length for my period is going to be 4 pi. So that means that if pi over 2 was my halfway point, now 2 pi is going to be my halfway point for my new graph, and 4 pi is going to be the ending point. So 4 pi is going to be the ending point. So now basically I just have to figure out what my halfway points are in between these, and that'll tell me what my max is and what my min is. So half of 2 pi is going to be pi, which means that I'm going to have a dot at pi up here. And then halfway in between this is going to be 3 pi. So I'm going to have a dot down here. So now I'm just going to connect my dots. 0 can't change. So I'm going to connect my dot here. Oh, I shouldn't change. Hang on. That's bad. That look is bad. So I want that to be the same height as this. So this should still be 1 right there. And then this point would be 3 pi. And that should be the same height-ish right there. So I'm going to draw my line. Oh boy. I'm going to connect here. And then as I connect here, I'm going to come back up. And then I'm going to attach it back to 4 pi. So I've just extended the length of this by 2. Okay, I've doubled the length of this. Now this should be something that as you work through with quarters, it should not be too big of a deal. Okay, now I'm not going to spend any time talking about vertical stretches or on the vertical shifts, because if you see a +2 at the outside of this thing, or if you see a +5 on the outside of this thing, or a -5 on the outside, you literally just take every point and count 5 up, or you count 5 down. That one isn't that bad. The thing that is a little bit trickier are the left and the right shifts, because the left and the right shifts make it a little bit more difficult to deal with. So since those are just a touch more difficult to deal with, I kind of want you to think about that a little bit more than the shifting up and the shifting down. Just because I think that they're a little bit more challenging. Okay, so let's go through the horizontal shifts. So this would be like left-right shift. And now what we have to really pay attention to is if I just have y equals sine of x plus pi over 2. This one is really, really straightforward because this just means that we are shifting the graph. We are going to shift the graph pi over 2 units. Which way am I going, left or right? Left. So I'm going to shift the graph pi over 2 units left. So if I shift the graph, if I have a plus sign here, I'm just shifting the graph pi over 2 units left. That's the same way that I would have before. So if I look at my normal graph of sine, and all of this applies to cosine obviously too. So if I have my points where I am at pi over 2 would be at 1. And then if I had pi would be at 0. I guess pi would be at 0. And then I have 3 pi over 2. And that would be at -1 down here. And then I would have 2 pi. So I would have my normal sine function looks like this. But if I shifted at pi over 2 units left, literally all I have to do is move this point here, move this point here, move this point here, move this point here, and move this point here. I've just shifted my entire graph pi over 2 units left. Now that should not be that bad because that's just a normal shift. It's just like adding or subtracting like we would have before. But now the thing that's going to make it a little bit challenging is I have to pay attention to what my period is. So I have to pay attention to what the period is of that graph because that's also going to affect everything too, right? Because if I were to take this sine graph and then shrink it, shifting it pi over 2 units left would not be, I don't know how to say this, it wouldn't be consistent with shrinking it. So what I have to do is I have to take the shrink into account with it. So if I had something that looks like this, where it was y equals sine of 2x, like 2x plus pi, this is not a pi unit left shift. Because right now, what I also have to take into account is this is going to shrink the graph, right? This is going to shrink the graph by a factor of 2. So if my graph is half as big as it was at the beginning, shifting it pi units is shifting it twice as much as it should shift. So what you need to do to figure out your horizontal shift, what you're going to do is you're going to take your number. So this is actually called a phase shift. What you're going to do is you're going to take this number and you're going to divide it by whatever that number was in the front. So you're going to take that number, which I guess if we want to, we can say that we have a function that could be a times sine of bx plus c. The way that I would figure out my phase shift would just be c over b. So all of the important information, amplitude would be the absolute value of a, period would be 2 pi over whatever your b value is, and then your phase shift is c over b. Okay, so that's what that thing kind of looks like. Now, one thing that I'm going to suggest to you is as you're working through this, I would very strongly suggest that you do the thing that we very, very first started with in Algebra 2, where you start with your parent function, and then you pare down into like little things at a time. So you do a little bit at a time. So like you take your phase shift, or you take your parent function, and then you shrink it, and then you do your phase shift. Because it's, hang on, I gotta yell at my kids. All right, I can't tell if I'm muted or not. Am I muted? Can someone just say yes or no?
You're not muted.
Okay, cool, thanks. So as I work my way through, you have to go left to right. You would still do your vertical stretch or your vertical shrink first. Then you would do your horizontal stretch or horizontal shrink. Then you would do this phase shift. So this phase shift, really what's happening is I would have to take this thing into account because I'm shrinking my graph. Then I'm going to shift it consistently with how much this graph or how much this is moving. So let's look at sine of 2 pi over or 2x plus pi. So if I take y equals sine of 2x plus pi, my new period for this thing is going to be 2 pi over 2, which is just pi. My phase shift, this thing is going to shift either left or right, pi over 2, because that's where this 2 comes from. So it's going to shift pi over 2, and it's going to shift left pi over 2 because it's a plus sign. So now I'm just going to sketch this. Now the way that I would sketch it is I would start out with my normal sine value. So I would start out just by graphing my normal sine, and I'm going to make this a little bit different. So I'm going to do all the way out to here because I know that my new graph is going to be smaller. So I'm going to give myself a little more room. So here's 0, here's 2 pi. Pi is going to fall right in between that. And then pi over 2 is going to fall here. And then 3 pi over 2 is going to fall here. So if you notice what I'm doing, I'm actually just, being very arbitrary with my graph. But I'm hoping that that's something that as you work your way through, you get more comfortable with. So now I know I'm not going to change the amplitude of this, so it's still going to be +1 and -1. And then I'm just going to put my dots here. So I have a dot here, I have a dot here, I have a dot here, and I have a dot here. And then I can connect my dots to see what my normal sine function is going to look like. Now, if you can't graph the normal sine function by this point, hopefully you can get it figured out pretty quick. Now, these are not supposed to be right angle or corners. They're supposed to be rounded. I just can't do it because this pen doesn't work very well. So now what I'm going to do is I'm going to graph my new function. I know that I'm going to have a new function which has a period length of pi, which means that my starting point and ending point are going to be here and here. So now I know that this point is going to be my smack dab middle, and these 2 points are going to be my maximums and minimums. So my max is going to be here, my minimum is going to be here, and I can connect these points like this. And that gives me my new function, but that just deals with this part. Now, if I want to do with the entire thing, I now have to shift pi over 2 left because I've already taken into account what this looks like. So I've now already taken this into account. So now I'm just going to shift the entire thing pi over 2 units to the left. Okay, so now if I shift pi over 2 units to the left, notice that this one was pi over 4, and this one was 3 pi over 4. So basically what I need to do is I know that every 2 tick marks, I'll erase that in a second, but that's worth pi over 2. Since that's worth pi over 2, I'm going to count pi over 2 left on every one of those. This point is now going to go here. This point is now going to go here. This point is now going to go way back here. I don't have room to do it, but it's going to go somewhere way back there. This point is going to go in between these 2 points. This point is going to go in between these 2 points. So I've shifted the entire graph left pi over 2 units, but shouldn't have changed the size of the blue and the purple. The blue and the purple shouldn't have changed, but every point in between the blue and the purple should be pi over 2 units to the left. Okay, now this is something it's going to require some practice because as you watch me do it, it kind of probably makes a little sense, but as you get to do it on your own, it might be a little confusing. So I'm telling you right now, what I'm going to have you do tomorrow is I'm going to have you graph something that looks like this. So your quiz tomorrow is going to be y equals a times sine of bx plus c, and then I don't know what letter they use for the other one, but plus, let's say k. I might ask you to do all of these things to it. All right? Now, all of this stuff is the one that's confusing. A vertical stretch, easy. Shifting it up, easy. This stuff in between here is what's complicated. So on your homework, which I think is the same kind of homework that I gave you yesterday, I want you to try out some of these problems to make sure that you can do it. Now, I'm either going to give it to you with sine or I'm going to give it to you with cosine. I literally don't know yet. I'm just going to pick one tomorrow. Okay, so whatever I see in the book that looks good, I'm going to pick one of those. All right, that's what you're going to be expected to do. So since it's only one graphing question, I only expect that to take about 15 or 20 minutes. So since it's only going to take about 15 or 20 minutes, you're going to have plenty of time to ask questions and to go through some questions tomorrow that hopefully should be able to fix whatever issues we have. Okay, so let me stop recording quick.